Good morning, my dear students. Before starting our next chapter, let us have some revision about finding the rational numbers between two given rational numbers. With an example, I will explain this to you. Find 5 rational numbers between -2 and -3. -2, I can write it like -2 by 1. The denominator is 1. Finding an equivalent rational number for this, I shall multiply a denominator by 10 and numerator by 10. So it will give us -20 by 10. The same way for -3 also, making the denominator 10, we get its equivalent rational number as -30 by 10. Now we shall have more than 5 rational numbers between -20 by 10 and -30 by 10. We can choose any 5 numbers from the above numbers. The same way, again I have taken another example. I am taking two rational numbers. Initially I had taken two whole numbers, -2 and -3. Now I have taken two fractions, 1 by 3 and half. First step is finding the LCM of the denominators of the rational numbers 3 and 2, which will give 6. So we get 1 by 3 equal to, make the denominator 6. So we get 2 by 6. For half, if we make the denominator 6, we get 3 by 6. Now, this will not give any solution to our problem. So, now we shall find equivalent rational number for these two rational numbers. 2 by 6 is equal to 20 by 60 if we multiply both the numerator and denominator by 10. Again 3 by 6, to make the denominator 60, we have to multiply by 10. So it will be equal to 30 by 60. Now we can choose any 5 from the numbers between 20 by 60 and 30 by 60. I have taken the rational numbers 21 by 60, 23 by 60, 25 by 60, 27 by 60 and 28 by 60. You can choose any number from the numbers you have got from the equivalent rational number. Let us start the chapter 2, Exponents. So in the part 1, we will discuss a little bit about the exponents. If x is a rational number and n is a positive integer, then x to the power n is equal to n times multiplication of the rational number x, where x is called its base, n is called the exponent, and it is read as x raised to the power n. So if I write 5 to the power 3, it is 5 raised to the power 3. Now, negative integral exponent of a rational number. For any non-zero number a to the power -n is equal to 1 by a to the power n where a to the power minus n is reciprocal of a to the power n. Let us see some examples where exponents are expressed as rational numbers. In the first example, we have an exponent 2 to the power minus 4. 2 to the power minus 4 can be written as 1 by 2 to the power 4. 1 by 2 to the power 4 means 1 by 4 times multiplication of 2, which is 1 by 16. In the question number 2, minus 3 to the power minus 4. So it is 1 by minus 3 to the power 4. 1 by 4 times minus 3 multiplication, that is 1 by 81, because the number of negative signs here is even, so we have a positive answer. In the third example, minus 2 to the power 3. For this we have to see it in a separate way. As we all know, a to the power minus n equal to 1 by a to the power n. Considering the denominator of a to the power minus n, which is 1, we cross multiply both the quantities, which gives us a to the power n is equal to a to the power minus n. So, in solving minus 2 to the power 3, we get that minus 2 to the power 3 is equal to 1 by minus 2 to the power minus 3, which is 1 by, again 1 by minus 2 to the power 3. Minus 2 to the power 3 will be numerator now. So, it is minus 2 into minus 2 into minus 2, which is minus 8. Question number 2, express each of the following as rational numbers. 2 by 5 whole to the power minus 2. It means 2 by 5 having minus 2 power to the both 2 and 5. It is equal to 1 by 2 to the power 5 to the power 2, which is 1 by 2 into 2 divided by 5 into 5. So, 1 by 4 by 25. 25 will be numerator and 4 will be denominator. So, our answer is 25 by 4. The same way, minus 3 by 4 to the power minus 3 is equal to 1 by minus 3 by 4 to the power 3. It means minus 3 by 4 we have to multiply 3 times, which gives 1 by minus 27 by 64. 64 will go up as numerator. So, answer is minus 64 by 27. In your previous class, in the chapter powers and exponents, you have seen that a to the power 1 is equal to a. So, here in this example, we are going to use that property of power and exponents. Write the multiplicative inverse of the following: minus 25. Minus 25 can be written as minus 25 to the power 1. So, multiplicative inverse is reciprocal. Actually, we can say the reciprocal also. So multiplicative inverse or reciprocal of minus 25 is 1 by minus 25 to the power 1, which is 1 by 25, and we will have the minus sign before it. In the second example, 3 to the power 4 into 1 by 2 to the power 3. So if I simplify, it is 3 into 3 into 3 into 3 divided by 2 into 2 into 2, it is equal to 81 by 8. So reciprocal of 81 by 8 is 8 by 81. Here are some points to remember. Number 1, if a by b is a rational number and n is a positive integer, then a by b to the power minus n is equal to b by a to the power n. Number 2, a to the power 0 is equal to 1. In the right hand side, I have shown how a to the power 0 is equal to 1. I have given the proof. Number 3, multiplicative inverse of a to the power n is a to the power minus n, or 1 by a to the power n. This is for today's class. Thank you and have a nice day.